Hey everyone, welcome to another Manufacturing Live. Sorry, I was taking a drink of coffee because apparently I can't read the clock. But welcome to the next episode. This is a pretty exciting one. We get to talk with Shawn Patterson from GSC. And before we get to that, I want to make sure everyone hits like and subscribe. And as a reminder, this year with Manufacturing Live, we're going to have different hosts throughout the year. So make sure you tune in because you may find a host that you like better than me. With that, we're going to get on into introducing Shawn. Shawn, tell us a little bit about yourself, what you do today, and then we'll start with the Q&A.
Well, my name is Shawn Patterson. I've been a machinist and a programmer for upwards around 34 years. And late last year, I got an opportunity to change my career a little bit, but still get to use my talents and things that I've used over the years to help other folks. And so I got on with GSC in outside of Milwaukee in Germantown. And so far, it's been great, and I'm loving every minute of it.
Very cool. So a little unknown fact, you and I had an opportunity back when the dinosaurs roamed to work together once upon a time, right?
Yep.
And so I know a little bit of the history, but you and I are reminiscing before the start of the show, even before we officially worked together, we worked together. So let's talk a little bit about your journey in machining. I know you worked out of Wichita and things like that. Can you sort of talk about how you get started? Because there's people watching that might want to get into machining and manufacturing. So let's talk a little bit about your journey.
Well, like I said, after high school, I roamed around, worked in different places in Kansas, and ended up in Wichita. And a buddy of mine, a good friend of mine, had been working in a machine shop for about 6 months and started telling me about it. I was like, "What's a machine shop?" I just never heard of it before. And so he told me, and I met him for lunch one day, and we went in, and he showed me around in the shop, and I just fell in love with it. And there was a guy in a little office working on a little old PC. This is back in 1988, I think, and he was using SmartCam. And I was like, "That's what I want to do. I want to be that guy." And he goes, "Well, you're going to have to learn how to be a machinist first." I was like, "Well, okay. How long does that take? Month, 2 months?" He goes, "4 years." So I went through my apprenticeship, and I got on with some company in Wichita and another after there that I was real fortunate. They had Mastercam at the time, and they didn't have an in-house programmer. And he seen I had a talent for 3D and machining. I loved machining. I still do. But and so I got an opportunity to be their in-house programmer slowly as I worked up through the ranks. And not everybody gets that opportunity. But I went from after I got out of aircraft after about 10 or 11 years, just because feast or famine. An airplane lands in Bangkok and a fly lands on the wing, and everybody gets laid off for a day till the flight takes off and the plane can leave again. So it was just feast or famine, and I got a little tired of it. So I went out into the general population and working and just regular machining. And I got on at the AGCO Corporation for a while, and I think that's where we were reminiscing.
Yep.
I was in the machine shop there and ended up being a crew chief. And I actually didn't know you had been there, but I think you was there before me. If
Yep.
our timeline is correct.
Yeah, that's what we determined is we missed each other by just a little bit. So
Yep.
before we talk about, and reminisce a little bit about the AGCO days, I do want to chat about aerospace machining, because there is a different way that machinists behave, whether I'm doing job shop or aerospace or high production. What skills did you learn when you were doing aerospace machining that is a little bit different than, like when you and I were working together doing more job shop work?
Well, aerospace work was, other than being correct, I felt the tolerances are actually just a little bit looser on most parts. But it's all about looks are a big thing. The part has to look good. It has to measure good. Everything has to be blended incorrectly. We didn't just take an end mill and then run in the corner and come out. We would leave it big and then go over this separate end mill and just whittle that corners out. Those little things I hadn't done in regular machining. We only did them in aircraft. And then as the years went by, regular machining picked up on those and started doing them as well. And there may have been other areas. I'm in the Midwest, and I've never got to work anywhere on the East or West Coast, and I know things are probably a little faster paced out there and learned, if you will, different out there different times. So, but yeah, aircraft was a little bit different. It was a little bit different animal. You'd have some just regular prismatic machining, and boom, you'd be right into some scrubbing, and then you'd be back into prismatic machining. Just lots of little parts. It's just amazing how many parts go into an aircraft.
But it's a little bit different how you hold the part too, right? Because you watch videos and it's like, oh, I'm going to take this one end mill and I'm just going to rough it at 65,000 feet per minute and the part's magically done. And you go to aerospace and they just laugh at you for those kinds of tricks because it doesn't fit how aerospace does machining, right? There's a lot of difference in how you hold a part and rigidity and flex. Remember you and I talking about doing thin materials and things like that, where you have thin walls and spars and those things, which takes a little bit different tact, right?
Oh, absolutely. Sometimes there was even some parts we'd make that it was a stainless steel material, and we would actually preheat treat it and then machine it afterwards to keep the walls stable because they'd get so thin. But yeah, a lot of vise work. And you didn't rip through it real fast because, like we say, and we'd have 30,000 walls sometimes you'd have to hold that were over an inch tall. So you just nice and easily just go down the side. You didn't go too fast through the stuff, or you'd had a mangled part.
Yeah, and we'll talk a little bit about when you and I worked together, and that was one of the things I learned from you when we were working together. But when we talk about AGCO. You and I both worked at the Heston facility, different times, but same era of that, which was a long time ago. But I was more on the field test engineering, building prototypes and going out and trying to break stuff. You were more on the production side. So what did you learn as you went through? You went to aerospace, you learned how to machine there. Then you went to a company like AGCO and Heston, where it's all about production volume. So what skill sets did you learn in that, and how is it different?
Well, AGCO was very much a production facility. I rolled my toolbox in, and the only thing I ever got out of it, and the whole time I was there, was my calipers. In fact, it was these calipers right here. Very much a production place. I was used to putting a fixture on a table and indicating it in and finding your X and Y, or putting a big vise on there and indicating it straight and getting it clamped down perfectly so it was parallel to the machine and perpendicular to everything. And none of that all that was done for you. They had a whole section just of tooling where all their machines, all their mill machines had a 2-inch plate and every 2 inches squared was a 5/8 reamed hole with 5/8 11 threads at the bottom, and you had two bolts within each fixture or each vise, and there was a 5/8 probe pin, 5/8 tall on everything, and there was just a one-line command. You typed in NDI, bang, 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 probe and done. The crew chief set up the tools and put them in your machine for you, and you hit cycle start. So, okay. And they didn't even have us an area to check parts. They were just that worked out. It was really neat to see that kind of, in machine shops I grew up in, you did everything from scratch almost every time you did it, and you set up the parts or whatever. You set everything up, and then boom, all of a sudden there it was just slam, pin, probe, push button, and that was something new for me. What I did see and learn there was I got to use some extremely expensive tooling cutters, because they had a crazy budget for machine shop. It was over $2 million that got handed through the tool crib window a year. And
the tool crib is wild, because I used to get to go to the tool crib and pick out drills and stuff for my truck, and going over there I was like, holy moly, this is not your Uncle Bob's garage.
No,
that's that's the real deal there.
Yeah, it was. They had their own sharpening equipment in there and everything. Yep. It was a neat place. I learned a lot that way, and I didn't get to really I only met a couple of the programmers, because I have an idea or two growing up through an aircraft. I'd get ideas and I'd give them to my boss, and he'd push them up the line, and then wouldn't be a couple of days and a program would come out. What is it you want to do to my setup? But they were really cool guys, and got to learn a lot there.
So before we go too further, I do want to remind everyone this is live. So please ask questions. We'll chat about them. Shawn and I are here not only to just reminisce about the good old days and today, but also to answer questions that you have, because Shawn, we'll talk a little bit more about the journey here, but Shawn has had a wide array of different manufacturing experiences. And what we're talking about now at the AGCO, part of the reason I bring it up is because I had a conversation at IMTS with a young gentleman that infuriated me a little bit. So what Shawn was just talking about of being able to prove out a program, set it on a table, probe it, and run it, and have it come out with a good part. I was challenged at IMTS by a younger gentleman that there is no way on planet Earth you could ever make that work. That you always have to dial it in. You always have to have cutter comp. There's no way that a program would work out of the box. And you and I both being at the same place, we know that that's a little bit different philosophy than what some people use in practice, right? But one of the things that you always told me when you were doing the machining there that was interesting is your value was based off of number of parts produced per shift, which is a little bit different than what you would have done in aerospace, correct?
Yeah, very much so.
So you want to explain a little bit about that? Because I can't speak for you. So you got to explain what that journey was like. Yeah. Even though I know it, you have to speak.
Yeah. There at AGCO, they had so many parts you had to do per hour. It's been a very long time for me to think about that stuff. But anyway, in aircraft, we didn't have that same. Most of the parts were bid jobs, and so we had it. We didn't want to lay around doing it, but it was more for quality's sake than quantity as to how quickly the parts got made. We AGCO, everything was so worked out and sandbagged a little bit, and you could literally take off half the day and not work and still hit the quotas. So, but aircraft I worked for a lot of the mom and pop shops. I never worked for Boeing or Learjet or Cessna directly. It was always for the smaller shops that did a lot of their work. And so we didn't really have a quota we had to get done. We just got on the job, we got it going, proved it out, inspected our first part, and then worked through it till it was done. It might be 5 parts, it might be 100 parts. It depends on how many planes they were building that year. So,
right. Well, and you mentioned the production part at AGCO. I think part of that too is the numbers were based on how many units they were going to sell per year and how many they were going to put through, right? So they had a schedule and a work order that was based on the projections and forecasts. So production is a little bit more we need to make X amount of parts to meet a production, where in aerospace they're trying to forecast for bigger type sales, for an entire plane versus I'm going to make 500 balers this year and I need 6,500 washers or something, right?
Yeah.
But a little bit different. And what's interesting about it is the mentality and the approach that goes into it. And that's the part that's always amazed me a little bit about it.
Right. Yeah, it is very, very much a different, almost a different lifestyle to go from one to the other. It took me probably a good year and a half to really wrap my mind around the whole big productions thing. Cause I went in my first day, and the guy was a real nice guy named Todd. He was supposed to be my trainer, and I put the vise on the table, and it took me forever, but I found a couple of toe clamps and some bolts and little knee blocks, and I got them up there and was indicating my vise in, and the guy goes, "What are you doing? What is that?" I said, "It's an indicator." And he's like, "We don't do that here. You see those holes?" And I'm like, "Yeah." And he says, "Just put a bolt in it. It's straight." And I just blew my mind. I couldn't hardly wrap my mind around that, because we'd done everything by hand up to that point. So it was a different whole mindset on everything. And then I got to where I was really good at the production. One of my jobs was to figure out the most rigid, fastest way to make a part with the fewest setups. And I got pretty decent at it. And that place actually helped me, because they did that too. There was a lot of times you might have a staged fixture, or when the mill-turn machines came out, that was a big deal, because there was a lot of parts that went from 2 and 3 and 5 setups to open the door, put a raw part in, open the door, pull out a finished part. And that was a game changer. But that was also the place at AGCO was when I worked. We had the Morisiki machines, or they did, and they had like 250 inches a minute rapid travel. And the next one they bought it, they stuck me on. They said, "Oh, we want you to learn how to run this machine." Well, they didn't. We just moved the programs, the cutters, the fixtures, everything over to the new machine, and we went from 250 inches a minute to 2,000 inches a minute. And wow, that's where I started seeing some really big changes in the manufacturing industry. It was just the machines. They got the machines where they make the parts, and over and over and over. They had for years, but is really wanting that speed. But Mother Nature is one of those things you can't just fool and, oh, I'm going to cut at 400 inches a minute in this titanium, and not, or nowadays, they even cut even more than that. They'll cut up to 1,500 inches a minute, but you got to have spindles for that. But so once they to take their normal machines and get more out of them, they invented the faster rapid travels, which was pretty phenomenal. I remember pushing the button as I backed up to slow it down. It was like, what is that? So
yeah, I mean, that's a whole different world, right? And then as you get more spindles and more horsepower through part of that evolution, then the programs you had that worked, now all of a sudden it's where we have to reprogram, right? Because now what used to take 5 minutes I can do in 2 minutes.
Yep. Reprogram, you change your cut step overs, change your step downs, spindle speed, surface footage always had to change greatly. And then they start coming out with the crazier cutters, and wow, that it just improved everything greatly. So
we before we go to the next step, we did get some feedback here from I hope I don't mispronounce this, Naloy, where he comes from in Bangladesh. There's no such hierarchy for machining. They still do things the old way. So we can appreciate that because Shawn and I went through that together as co-employees at a company. After AGCO, you and I we ran into each other, right? We both worked at a little company, small company called Prototech Industries.
Outside
no longer
of Topeka,
here.
Kansas. Yep, good gone.
Outside of Topeka. And we did a mix of things there, right? We did some military government, we did some aerospace, we did insane job shop stuff that we probably shouldn't have been doing.
Those little poor machines took a little beating from us.
So everyone sort of heard me talk, and I have a fondness for Fadals, and that comes from the time that Shawn and I had there.
Same here.
So before we get into that, because I do want to share our ball screw story, but before we get into that, Naloy also asked a question right now. What does it take to be a CAD CAM application engineer? What things you should be able to do or learn?
Well, I've only been a CAM application engineer since September last year, so I've always been on the other side of the desk at the demos and stuff like that. So my take on it is I'm very happy to be here, but what I'm glad I'm bringing with me is the experience I learned. Now, not everybody has the time to go out and spend 30 some years in machine shops just so they can come do this. But if you have some experience in machine shops, so that you can, when you're talking to your customers, or you're helping your customers, and you're going through some of their pains, you can feel it with them, and they understand that, and they know you're there for them. That's how I feel anyway. I'm not here to fix their day-to-day problems. I'm here to get them up on their CAM software and help them get their jobs done. But I do feel their pain, as I went through it as well.
I think
go ahead.
I'll jump on there with you, because I was a CAD person for a while, and then I was a CAM person, and like we worked in the real world, and we did a lot of that stuff. I started mine on the fabrication side, lasers, and then moved into machining. I think the CAD, if I'm being honest, CAD's easy. Let's be real. CAD today is pretty easy. Back in '99, when I started doing CAD, it was a lot different world. But today, everybody learns CAD by the time they're out of high school, it seems like. The big thing when you get into the manufacturing roles, like robot programming, CNC machining, nesting, having some real world experience and understanding is the skill set that's sort of missing, because I can set any lead in or lead out however I want it to be, but if you have the background and understanding of what that lead in and lead out's doing in the real world, you're going to be able to help the customer more than just be like, oh, it's just axial at 6,000 inches a minute. Just hit the button and go. That's not a good recipe to help a customer. So it's really about the value add, because with CAM, you're connecting to the real. And what I mean by that is, in CAD, if I go put a fillet or a fillet for the salespeople on a 0.375 inches, it looks good and I just ship it. But in machining, if it's a 3/8 fillet, now I have to use a cutter that's smaller than 3/8. Well, how does that affect the rest of the pocket? Does it have to be 3/8? Could it be a 400 so I don't have a sharp hit in the corner for chatter? You only get that knowledge if you have experience like Shawn does, or like other people that have actually machined it and had to have that finish. Would you agree with that, Shawn?
Absolutely. Yeah, absolutely. Yeah, being a CAM person and you're talking to somebody that's you're a customer, in most cases, then I'm not here to do it for you, but I'm here to help you. I'm here to give you that little bit of incentive or that little extra. Well, maybe you could try this. This worked for me before. And I think that's one of the things that's kind of lost, not on all CAM guys. I've known CAM guys all my life, and AEs, and Mike being one of them, of course. And some of them were some of the best machinists I'd ever met before they got into it as well. And some of them were really good at the software, just they couldn't understand what I was doing or what I needed to try to learn from them and their software. So I think it helps a lot that I have some experience. I have a lot more experience than some people probably do when they go to be an AE. But I loved camming, and I loved my job as a programmer, and I did it for a long time, and never really thought about an opportunity like this, and it just kind of fell in my lap, and I'm running with it because it's something new, and I just wanted to try it out.
Yeah, well, and I think the other thing too is like it's a little bit less today than it used to be. When I started as an AE for CAM, if you went out to demo in front of some grouchy old guy that's been machining for 40 years and you couldn't hang your chops, you just got eaten alive.
Yeah, they will eat you alive.
It's like if you're doing nonlinear simulation dynamics, if you're going to go talk to a PhD and you don't even know what nonlinear is, they're not going to listen to you, right? I mean,
right.
There's all different kinds of specific disciplines that you have to be good at what you do. Electrical, right? We're talking about Claire from your team, right?
Exactly.
She has her chops in electrical, and if she couldn't do it,
she does.
She'd get eaten alive in front of a customer that's all they do. So you think about it in that light.
Absolutely.
There's a couple other questions here that we'll ask, that were asked. The next one is, what's trending in engineering right now? Do you want to talk a little bit about that, or do you want me to answer that one?
Well, I'm not an engineer, and I don't profess to be. So I'll probably let you handle this one.
Okay. So I deal with the worldwide business for Dassault. So I see sort of like a global scale, not really a microcosm of it. What I see training in engineering right now is a lot of design for manufacturability, because we're sort of at that point where we can design any widget, but we can't necessarily make it. So there's a lot of focus on how do I streamline the process for engineering to make it more manufacturable. We're starting to see that merge back how it used to be, CAD, CAM together. How do we make the most efficient design to be able to manufacture it for the best cost? That's what I see a lot of these days. Obviously, I'm in that discipline too, but that's a lot of the questions I get. The next one is for you, I believe, Shawn, which is, as a CAM application engineer, what is it you actually do in manufacturing? Is it more with steel metal manufacturing or other types?
No, about anything. I've cut all kinds of materials in my career. If you're talking about just the customers I deal with, is that what he's referring to?
I think he's more asking about, like, what does your job entail? Like, are you just doing fab? Are you just doing CNC?
Oh, no. Most of what I do is CNC. I haven't been doing this long enough to run across the fab stuff yet. I'm very familiar with it. CAM's what I was hired for, so that's kind of what I'm doing right now. I spend a lot of my time. I'm learning the 3D platform in Delmia, which is pretty awesome stuff. Having been a big time master CAM guy, and I learned CAMWorks back with Mike back in the early 2000s, mid 2000s, and So I've used it, and I can say the Delmia is definitely way above it in as far as power and everything. But otherwise, day to day, I spend a lot of my time just doing stuff for customers. We recently had a customer. I built a tool list for them, the whole 3-dimensional tool list, 80 tools for their machine, and just spending my time doing the work in the software, trying to find new things and learn new things about it. I recently have purchased a CNC router so that I can kind of practice this on my own here in my own little shop. I've never actually owned a CNC myself, so this ought to be fun. But other than that, I don't really cut much or program for anybody. That's really the customer's deal. I'm just here to help them and point them in the direction they need to get to get their projects done.
Well, and the customer you referenced, I know you were out with my team last week out there doing training as well. So part of the application engineer process is presentations, support, training, answering questions about the general. And, for the fab piece, you mentioned Delmia, we just added nesting in some of our specific fab stuff, which is near and dear to my heart, starting in that world. So we've added some of that as well. But the process of your experiences, you programmed in CAM, but you also ran the machines. So you had both sides. So when we talk about when we were at Prototech together, right? You shared a picture of me from a long time ago when I had less gray hair, but please don't share that too often. That one made me look very young. The process at Prototech is there was only a handful of us, and we all sort of worked together and did what was needed to make it successful. And we did the outer turbo housings for the M1A1 for inspection. We did some aerospace stuff for the 777s. I remember doing those little hex nuts. The stainless steel ones with the graphite heat treat. And then we did lots of fab type stuff. And one of the things that always stuck out to me is, you remember the band pole spreaders?
Oh, yeah. Yeah.
Yeah. That I came from more of the manufacturing side of the traditional machining, right? We just put them in vices and we make soft jaws and then we do that.
Right.
And I always remember that because that's the first time that I learned about doing tabbing.
Tabbing, yeah.
And the aerospace method.
Right.
So talk about a little bit about that process and what we went through at Prototech, because you and I can talk for hours about it. And I do want to get to the ball screw story, but just because it just makes me giggle every time we do it. So talk about the experience there and, how that was sort of a culmination of everything you'd done to that point, because we did run thousands and thousands of parts for gun stock inserts, right?
Yep. Absolutely. Oh, it took me a while to figure out what the part did. It literally spread poles, band pole spread. It spread poles apart, and it was just constantly changing radius. And it was about 4.5, 5 inches thick, and we just had no way of holding it down. Little small shop. We didn't have a lot of old fixturing to go back and say, hey, we can alter this and make this work. So we just had us a flat plate. We bolted down to the table, and literally used our excess material as a way to hold the part down. So we just programmed where the 1/2-13 bolts that we're going to use to hold it down, and we'd used just 1/4-inch pins in 2 places. And as we machined it all out, when we did the profile, we would, in those places where the tabs were, we would leave 15 thousandths extra just right there where the tabs were at. So when it was flipped over, relocated on the pins, so that it was in exactly the same position. We could do the same thing, machine the whole time outside and inside complete, except where the tabs were. And then finally machine down, leaving another 15 thousandths, which left you 25, 30 thousandths. You just broke off, and then you just use a little 90-degree die grinder, sand it off, and blend it all in, and you were good. And that's things I learned in aircraft. And those particular parts, I believe, were for Goodyear, which obviously wasn't aircraft.
They were for the Topeka Police Department, weren't they? Weren't those the ones for the police department?
Well, they could have been.
So this was a good experience in design for manufacturability, because you remember those parts. Somebody modeled them up, and every wall was a chamfered wall,
Right.
Nothing was straight up and down. They had little itty bitty fillets in the corners. And then they had a super tight tolerance where the pipe went in with that tap on the back, the hole in the back. And everything was way over engineered to be this super high tolerance to where the parts were outrageously expensive because you had to sneak up on them with very small tools.
Yeah, I just tapered tools.
Yes. And we did those in a 3-axis machine with full tapered walls, like you would run them in the Bridgeport in the corner. And I remember those vividly because we did them right around Christmas, because I remember those running through Christmas.
Through Christmas, yeah.
Yeah. Yep. And that was very shoestring budget. And that's also where you and we had a lot of fun there. We learned why people don't use a tool called G0.
Right.
If you don't know what G0 is, please feel free to go look it up. It has its place for somebody.
They still make it.
They still make it. I looked it up.
I'll be darned.
Yeah. It is a tool that probably served its need at one point, but it was like the precursor to any CAM system. And you talk about doing things the old way, like Naloy mentioned, right? We had a culture challenge there, because there was the person that started the company was an old school machinist. He believed you could do everything on a Bridgeport you could do on a CNC. And then if the spindle said 10,000 RPM, that's what you ran it at nonstop. You never shut it off of 10,000 RPM. Regardless of the rigidity of the machine, you just run 10,000 RPM. He was max effort before max effort was cool.
Yeah. Consequently, we kept an extra spindle laying around just for that reason.
Well, and that became an interesting learning experience for me, and I think hopefully for you as well, because we had a challenge of the owner wanted to run it a certain way, and then was always upset when the machines were constantly broke.
Yeah.
And then it was, well, you guys just aren't treating my equipment good enough. But if you had it running at 7,500 RPM for the correct feeds and speeds, he would walk through the shop and turn it up to 10,000.
Yep.
And we had little itty bitty 40 taper machines, and we were doing this big, nasty, dirty steel stuff for Goodyear, which we shouldn't have been doing, which is where the picture comes from that Shawn has of me, because I was actually out there facing everything and squaring up blocks to try to reduce the problem. But we were also buying tools from eBay to run production. So it's one of those things where it takes all kinds of companies to do manufacturing, but the fundamentals are still the same. Wouldn't you agree with that, whether I'm doing aerospace or production or job shop?
Yeah. Yeah, they are absolutely the same. You can't, like I said before, you can't fool Mother Nature. You can only do so much in different kinds of materials. So, but yeah, we had a lot of fun there. It was a pretty cool place.
We did do a lot of fun. We did some cool stuff. I mean, I don't know how many people ever get to see the outer turbo housing of an M1A1 tank, right? And what it takes to refurbish one of those. To me, that was always a cool thing, right? And using that nice 5-axis CNC or 5-axis CMM to do all the probing was pretty cool.
Yeah, those were neat.
Yeah. So let's talk about the ball screw story. I'm going to let you tell it because you were there when it all fell out. So let's talk about, we had a machine that,
oh boy,
it couldn't cut a circle within 30 thousandths or something like that.
The X-axis ball screw.
Yeah.
It was so wore out. I don't remember everything about it. Man, it's been a while ago. Was that the second machine on the right when you walked in from the office?
Yes, it was number 2 machine.
Number 2 machine.
That you couldn't use for machining if you had to do circular interpolation because it couldn't do it.
Yeah, it couldn't hold a circle.
Yep.
I can't remember a lot about that machine, to be honest about it.
When they came out to do the service on it, because when you would run it in X to the X positive, it would growl, remember?
Oh, it growled really loud. I remember that. Yeah, now that you say that. This is going to take a memory remembering here. So, yeah, then the one next to it, the machine only could drill. You couldn't mill with it. I'd never seen that before. I'd never run across just a drill CNC. But yeah, that thing was the x-axis would just scream, and he didn't really seem to have a big problem with it.
Yeah.
I don't know. It was it was a crazy time. Those are a long time ago. I got to remember some of that stuff.
That was machine scheduling before machine scheduling, because the equipment, some of the machines were so wore out, you had to schedule only certain jobs to run on them. But
Absolutely.
The ball screw story, I remember it because it always makes me giggle. That we had the machine was so wore out, and the reason it was growling and X positive, they came out to service it. They ran the table all the way to the right, and every ball fell out of the screw.
Oh my goodness, that's right.
Yeah, remember that?
Now
we kept telling the owner it was wore out.
Oh my
and
goodness!
Ball screws.
Mike, you got to have this machine looked at.
Yeah. He's like, "Oh, it's fine." And the tech finally came out and looked at it, and all the balls went ding, 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 ding down in the tray. In the
coolant, in the coolant tray. Yeah, that's funny. I forgot all about that. Oh my goodness, that was a long time ago. Yeah, that's crazy stuff right there.
There's highlights from that era that I remember, just because if you don't laugh about them and it's not funny, it's really just sort of
depressing.
Sad. Yeah.
Yeah.
So after you and I sort of worked together, we fast forward to before you came to GSC. You did some really cool stuff with wheels, right?
Weld Racing, Kansas City, Missouri. That's the only time I've ever made wheels. It was an awesome learning experience. I met a programmer that Jay Ryle is his name, and he's a good friend, and he's a great guy, a hell of a programmer. Taught me quite a few things, and I thought I knew quite a bit, but he taught me even more. But yeah, I'd never been in the process of making wheels from lathe forms, or they're forged spun lathe forms. And they have a good process down there, and a lot of good people working there. But it was very interesting to take them lathe forms and cut the patterns in them big deep wheels for their race cars and stuff, and miss everything. That was the trick, is not you didn't touch the sidewalls. So that was a lot of fun. I enjoyed it greatly. Like I said, I got to learn a lot more about the same mills I've been running for years. I just hadn't used them like that, and it was very interesting, and I'll never forget it. It was a really cool experience.
And it was all some of them were pre-anodized, right? That came in already pre-finished. Yes. And you were highlighting. So some of it was bulk removal, right? Because you were actually cutting the profiles and contours, and then on other wheels, you were using machining as an aesthetic to highlight the process, right?
Right. They're regular racing wheels I sold to individuals, just cars for your cars and stuff. Those wheels, we would do the lathe form and finish it out and send it off. We'd polish it and send it off to a place near you, I think, in Nebraska, and they would anodize it, black anodize, and bring it back, and then we would machine it. And it had to be sold. We had to be able to sell it right off the machine. So that was interesting to keep that, to cut it in such a way that the anodize didn't try to chip or peel off. And some of those designs were absolutely gorgeous. I'd never done stuff like that, an aircraft or regular machining. Who does that? So yeah, that was really neat process that they have there.
Yeah, well, and I think it also comes back to the point of there's all different types of machining, right? Some are
all kinds.
Some are for structure, some are for aesthetic. Most of the stuff I do, signs and things like that, that's all aesthetic, right? So I fall a little bit more these days on the what you call the artsy stuff, right? And then there's the production, like at AGCO, or like what we did at Prototech, where it's like, look is important, but not as important as function, right?
I referred to it as meatball machining, kind of like MASH, the meatball surgery. I referred to it as meatball machining. They had their parts down to where they just needed a shaft, and they could get that shaft in stock size, and we just need to drill 2 holes in it 4,000 times. So. Yeah. And that's not the bulk. I mean, there was some other neat stuff. The combine headers for corn headers and stuff, those would be welded by welders or robot welders, and then we had to bring over in fixtures and drill all that. Everything had to be correct to get the right placement for everything, or they wouldn't work. And by the time we got them, they were kind of expensive. There's quite a bit that goes into a corn header. Yeah. Just that one section, it might be a 20 row or a 30 row, and just one section. There's a lot of work lot of fabrication, a lot of welding, and the machining was actually the easy part, but you could mess it up, and it was very interesting how we did those things.
Well, as a person who worked in a family business at a dealership for AGCO and Gleaner, I can tell you that having those drilled in the right spot is the most important thing on the planet when you're out in the middle of a field replacing those.
Right.
Because, funny story, I was just going to be a diesel mechanic, broke my neck, was looking in the catalog to figure out what I wanted to do with my life, at 18, have no clue what's going on. And I was like, I hate all those engineers that design shit for ag equipment that doesn't fit in the field. I'll just take up manufacturing engineering. That sounds like a good trade. And then lo and behold, my first job is working at AGCO Heston. And all of a sudden it was like, oh yeah, now I know there's this tolerance stack up and there's all these things that go in it. And so best intentions end up with the person that can machine it in tolerance and in spec. But you don't really think about that when you're an 18-year-old kid out in the middle of a field on a 100-degree day trying to replace parts that don't fit.
Right, exactly.
So we do have another good question, and I think this one is right up your alley. And that is, what things are different now from when you were beginning CNC machining in terms of software capability, machine capability, and the way parts are programmed?
Well, back in the day when I started, and there's a great, huge difference. Machines were heavy duty, but they weren't fast. They were very slow compared to today's standards. They were very slow. You did big cuts. You took a face mill and you went in a 1/4 inch deep and you chunked across that part to square it up, and then you let it cool down. Whereas today you take a lot, intensely faster passes, a lot less material with coolant and all kinds of things like that, and you can get the part done a whole lot faster. There's just it was a different time, like different equipment. Even the 40 taper machines were, I wouldn't say they weren't better built. They were just sturdier built. And it's kind of like today's cars. They're good. They're very precision, but they weren't the big 70s bulky, heavy duty cars. And that's just the same kind of thing. It's we took big cuts before we took the little cuts, and now we take lots of little cuts to end with another little cut. For instance, at Weld, I could use a roughing end mill in one of those machines for almost a year because of the way we treated the tool. It wasn't so much get the part done fast. We did get the part done fast, but we did it and kept our tools alive for a great deal of time, which that did not happen back then. You chunk through a part, you might as well just change all the inserts because it was done before you put your next part up. Earlier I mentioned some heat treated stainless parts that we would heat treat them first, and we literally used an end mill per part because it was worthless when we got done. Sometimes we'd have to change it to go back and finish it up. Just it's hard material, and the cutters were different then. Geometry was a little bit different. It was a little cruder. Here we are in the future, and there's a whole lot more science involved with it, and things just work a lot better. It's like the cars. You can go out and buy a cheap car that's really well built because in precision tolerances, the machines were better that make the parts. And so that's what I kind of noticed. There's all kinds of different ways of triquartal machining wasn't around back then. It was just pass, and we didn't have a radial chip thinning where it would do the math for you in the CAM software. The CAM software was 2.5 axis. I remember using an old AutoCAD and SmartCam, and I would do a side view and pick all my points in Z and then add them manually to each pass in SmartCam to get a 3-dimensional pass out of something. Take hours and days. Yep. So, and that's done now. You can do it in just click seconds. And it's just huge changes during my career. Even I can't even imagine what it was like to go from a blacksmith to a machine shop that was running by belts, swinging everywhere, and turning down your own. When I first started, there were still tape machines being used. I was young. I didn't know how to set them up, but I ran them. And that was crazy. And then they come out with a little red digital readout. You had one number, then you could flick your switches over here to get a different number, what you wanted to see. No screens to watch. So I wasn't out anything because I didn't know there was ever going to be screens to watch. That's just what we knew, what we had. like cell phones today. We didn't have cell phones. My son was born in 1999, and I got a great big bulky phone.
Yeah.
I carried it around with me, just same thing. And just things change, get better. But yeah, back then it was a different feel on things and different way things were done. And those guys were good at it. So, it was just crazy.
Well, I think I had that old Matsura, and that thing, for being an 84 model, was still perfect. You could still cut a perfect circle with it. And I always equated a little bit more to before machines became mainstream, they were a little more one-off, custom built per job, right? And so they were heavier, and they were very dialed in, and you would have someone come out and manually turn your ways when they get wore, and like that was like shoeing a horse, blacksmith type stuff. But the machine would last forever if you took care of it. Where today you have some really good heavy duty machines, but then you have a lot of machines that are like compact Hugos, where you just run them until they die, you throw them out, and you get another one, because they're not built like they used to be built, because now we're a little bit more mainstream, a little bit more mass market, right?
Yeah, because you start a production facility. You want to get a bunch of machines that are precise, and you want to keep your maintenance down. So in 3 to 5 years, you're going to start replacing them and just turning them out, regardless of what shape they're in, because you're going to have a new one that's going to be back to no maintenance and stuff. So, and that's kind of where they've pushed the making. I'm not going to bash on the machines nowadays. They got some really cool equipment out there, stuff I would have never imagined back in the early days. But that's kind of where things have gone to where just I want a great machine that works for 3 to 5 years, and then I just want to get rid of it.
Yep.
And I want a new machine. So, and that's kind of where they've done with their engineering. So that makes the machines a little lighter duty. They can handle the cuts, they can do the work, but for a little bit more limited time before you got to start replacing parts. And or back then, those old machines, the Matsura that Mike had, was one of those machines, at least on the tail end of it, that was a little heavier built and could last a lot longer, providing you give it some normal maintenance and replace a part here and there. Those machines were heavy duty. They were meant to last 20 years.
Yeah. But if it was fast in 84, it is a dinosaur speed-wise today.
Oh, absolutely. Yeah. There's no way they could keep up.
The only ones that I've seen that's a good balance that have really impressed me is the DNs, because the DNs have a heavy casting like my old Matsura had, but they have the performance and the controls and the options. Like that's the machine where I got to find some extra money to own one myself, because I could do some damage with one of those. There is another question that came in, and this one has a cheeky smile at the end. So I think someone might be fishing a little bit here. It says, can a CAM application engineer create prototypes efficiently? Perhaps like creating a battle bot, for example. So can you create prototypes as an AE?
I suppose like parts and build my own robot and stuff?
Yeah.
Is that what he's referring to? Yeah. I mean, I could on my own time. I don't do it while I'm working, of course, but yeah. I'm not an engineer, and so I don't profess to be one. So I've built houses. I just built the greenhouses. I can come up with all kinds of things once they're needed. I'm not a good person for I just thought of something crazy. Let's go build it real quick. I'm very much a needed. If it's needed, I can think of it. I can come up with it. I can do my own engineer, if you will. But yeah, you could. I've known several CAM guys who were race car drivers, and they built a lot of their own parts for their cars. I like riding motorcycles, so I've built motorcycle parts. We called them government jobs back in the day, and when I was in the machine shops. As a CAM AE, I don't really have access to the machine shop anymore, so I don't really build much, and so that's why I'm buying a little CNC router so I can do a few things on my own here at my house, my farm. My wife and I have a little farm, so.
Yeah, and you just bought the maker's version, so you can work on your own stuff on the side with your router. Exactly. Which is separate than your day job of helping other customers be successful.
Right. Yeah, I keep that on my own personal software and everything, and computers and all that. So keep all that separate. And
it seems like in some of the comments, and Ian, who produces this and makes us all look good, He thinks there might be a little confusion when you see applications engineer.
Yeah.
What application engineer means is that you're a technical expert in a certain field. And in Shawn's instance, he's a technical expert in manufacturing.
Yeah.
He's not a mechanical engineer or a CAD AE, which is an engineer for CAD tools, right? He works more on the downstream part, which is what I do these days as well. We're more on the doing and making it happen side of it.
Exactly. I take the models that the engineer has designed and FEA tested and whatnot like that. And then I take them in, and if it's a brand new part, I'll take them in and start camming them. And I get to a point of, if this can be done, if you've got some radiuses or some areas that can't be done, I let you know why, see what we can do to change it. Other than that, then it's my job to take that model and go make a real part. And in some cases, consistently keep making that same real part.
Yep.
So not just find a way to make this really quickly, find a way I can make this for the next 10 years.
And you're still a CAD person because you still have to draw all that stuff and modify all of it, but you're not the mechanical engineer side of the fence where you're going to run SolidWorks simulation or Simulia or something like that to validate whether the frequency is correct when the part's made. We look at it more from how do we hold it, how do we produce it, and is it going to chatter because you made it 30 thousandths thickness? Right.
Exactly. Do I need a little more meat here? Yeah, I can use the software. I love SolidWorks. I've always been a big fan of it. Mike started teaching it to me back in, like I said, 2007. That's when I first got to see it and CamWorks. And but I don't need to as a machinist and a programmer, I don't need to invent anything. The only inventing I do is fixturing, how I'm going to hold the part, and it's actually taught me a lot. It's just that I think of things I need to make something else. I'm not a Mike. I can't think of, I'm not an engineer. I don't engineer anything. I don't even have a degree in it. My son does, which I'm very proud of, but I don't. Yeah. I don't actually invent anything. I invent the way to make it. I was asked once in a job interview, and they give me a part and a selection of 6 different machines. And he says, which machine can you make this on? And I said, actually, I can make that part on all 6 machines. Whoa. Oh, wow. Oh, I didn't think of that. You can. I said, yeah, you can. So it would have took longer, but I could still make the part. So, and that's what the experience in the machine shop does and everything. So it teaches you what you can and can't do. You can't fool Mother Nature. You can only do certain things and ways, but you can skate around them with a little help doing different things. So
there's a couple more questions looks like coming in. As someone who is from an electrical engineering background but then got into CAD and CNC machining because we couldn't make things we wanted, what's a good role for me in a modern machine shop? So he started out in one discipline, sort of migrated a little bit like we have.
Yeah. And some of the smartest people I ever met were electrical engineers. They are usually really smart cookies. What's a good role? I mean, well, yeah, I don't know. I mean, experience is experience regardless of what background you come from. I guess I'm not sure how to answer that question.
I'm going to take a stab at it, and I think it's a little bit more manufacturing engineering-esque. I don't believe heavily in titles, if I'm being honest.
No, I don't either.
If there's a need, we have to have a solution, right? It doesn't really matter because we got to do what's right for the company. And the goal of a company is to make money and make profit to support families everywhere. That's the goal. So how do I best fit that? And if you have an electrical engineering background and you get into CAD and CNC, I could see your natural progression getting into the fixturing design and how can we efficiently make that part before it gets turned on.
Yeah, I can see that too. Because you'll get the experience about stuff like that as you go. Being a background of electrical, you're gonna bring an X amount of experience with you and common sense and mechanical knowledge. So that's a huge help. But yeah, I could see that being able to switch over to that pretty quickly.
Well, and part of the reason I say manufacturing engineering, and somebody already beat me to it on the response is when you get into manufacturing engineering, you also start getting into PLCs and airlock work holding systems and things like that for mass production. And electrical engineering is needed when you start playing with PLCs and connecting and doing quick clamps and things like that. So the fixturing component of it is not like, oh, I got a 6-inch Kurt vise and now I'm going to make a soft job for it. Today's manufacturing engineers get into a lot more automated systems and pallet pools and things like that.
That's a little bit where I think I mentioned in passing conversation before. I'm in the Midwest. We don't see, in the center of the country, we don't see there's a lot of manufacturing here. There's a lot of big manufacturing here, but we don't see as much as you go out east and out west. And even in my travels up around Milwaukee, working for GSC, I've seen things that I just wouldn't see in my normal day travels in machine shops in the area I've grown up in, which is Kansas, Missouri. There's stuff here that's cool. I'm actually kind of getting towards the end of it where I'm not going to see much of it anymore, actually doing it, so I feel I'm a little jealous of the young people out there that have the opportunity to go out and do and experience this stuff that's happening now.
Yeah. Well, and I think some of it's changing too, because traditionally in the Midwest, we've always had people to do the work. So we've never had to be quite as innovative. That is drastically changing as I see in my job because, it's a people problem.
Yep, it is. It's happening to everybody.
We're getting close to the top of the hour, but I do want to I have to say this last piece. So Elliot Evelyn, I hope I pronounced that correctly, Shawn, posted, I've had the privilege of working alongside Shawn. He's a true machinist and a fantastic CNC programmer, # problem solver. And I couldn't agree more with that.
Thank you, Elliot.
Shawn and I worked together. I learned a lot from Shawn that carries me today with my bullshitting ways. So, there's a lot of talent behind the person on the other end of the screen that it definitely helps solve problems and can actually make things work. So, with that, we're coming up on the top of the hour. Do you have any final thoughts, Shawn?
Oh, not many. I hope I've been seeing a lot more young people jumping into the manufacturing scene, and it makes my heart soar a little bit because I was a little depressed about it a few years back because it just seemed like nobody was taking. And I just want to say, keep at it. You'll run across your hard days, and you're going to have some great days. You're going to get to see and be part of something new coming out in the world that will be heard of and seen and talked about forever. So hang in there. It's a fun ride if you want to jump in. And
it's also a small community. You get into it, and it's amazing how many people you will know around the world throughout your career, because people move and transition, and you really you never stop learning. That's what I'll say.
Yep. Very much so. Yeah, to this day, I've never stopped learning. I've learned stuff all the time. Last week, learned a bunch of stuff. So with that, Shawn, I can't thank you enough for being on here. Next Thanks
month,
for having me.
Yeah, I mean, dude, I can't thank you enough. It's always a privilege to get to hang out with you. The episode next month will have a different host, so please tune in. I think we're going to have David from our UK facility. We'll be talking a little bit outside of the usual realm of who Mike knows for having discussions. So please tune into that. Also check out all our live stuff. Please subscribe to this channel so that way we can continue to pay the bills and borrow more time from people like Shawn. Thank you for joining, and have a great day.
You do the same. Thanks, Mike.